Okay, welcome back. And now today we're going to talk about concavity and points of inflection. So now that we know that how to determine when a graph is increasing versus decreasing by looking at the first derivative, another question is, if it is increasing, is it curving upward or is it curving downward? Because you could have an increasing function that does either one of those. So that brings up the idea of concavity. Okay, so when we talk about concave up or concave down, that we're talking about how does the graph curve, if it does curve, right? So we know when a function is increasing, but how do we determine whether a curve is concave up or concave down? Because if we look at this, versus that, right? Both of these are increasing functions. Okay? But if we look at the tangent line here, and we look at the tangent line here, and here, right? Pretend that hits. Okay? So what do we notice? On this one here, as x increases, let's say, the tangent line is getting flatter, right? So it's not increasing as much. And as you go across here, it seems like the tangent lines are getting steeper and steeper. Okay? So, here the slope of the tangent line is decreasing, and here the slope of the tangent line is increasing. So it seems that if we can look at the rate at which the slope is changing, right? Is it decreasing as x increases, or is it increasing as x increases? So here's the thing, is if the derivative increases, excuse me, if the derivative increases, right, as x increases, then we would call this concave up. If the derivative is decreasing as x increases, then we would call that concave down. And of course the graph shows that as well. Okay? And so that leads to our next definition of concave up and concave down. See you next time.